This is the View Pre-Calculus course. We're doing topic 8 today, which is solving trig equations and finding the zeros of trig functions. So we're going to start right in with example 1. But a couple things to remind you as you walk through these, right? So there's sort of 3 steps to this process. Number 1, make sure one side of the equation equals 0. Now, in examples 1 through 3, you're asked to find the zeros, meaning you'll just replace the f of x with 0 anyway, so one side is already 0. But if it's an equation like in examples 4 or 5 or 6, you'll have to move stuff to one side to make it equal 0. Then you're going to follow all the guidelines for factoring that we did in the last section, which was topic 7. And then you're going to set each factor equal to 0 and use your knowledge of the unit circle to solve. So let's walk through that. So I start by saying that f of x is equal to 0. Right now, when I go to factor this, I look for a GCF. And remember that the stuff inside a trig function is part of the trig function, right? So there's no such thing as just tan. There's tan x here, right? So my GCF is going to be this tangent of x, right? I can take out a tangent of x. And after I factor out that tangent of x, the two terms that are left are going to be a 2 sine of x and a negative root 2, right? So either the tangent of x is 0, or 2 sine of x minus root 2 is 0, which if I solve down to this sign, I'd add the root 2 over and divide by 2, so I would get sine of x is a positive root 2 over 2. Well, now it takes us thinking about our unit circle knowledge, right? On the unit circle, the tangent of the angle is the y on the unit circle on top of the x in the unit circle, and that's supposed to equal 0. Well, if you multiply the x over, what that's really asking you for is where is the y on the unit circle 0? And the answer would be here and here and here again, because notice that 0 and 2 pi both have brackets. So my answers would be that x, because it's not theta in this situation, it's x, would be 0 and pi and 2 pi. So that's my first 3 answers. Over here, I want to know where the y on the unit circle is a root 2 over 2. Well, that's going to happen at the pi over 4s, right, those 45-degree angles that are above the x-axis. So that's going to be here and here. So my other 2 answers are going to be pi over 4 and 3 pi over 4. And so there are 5 zeros on this interval, and there they are, right? So that's my example 1. All right, let's go ahead and dive right into example 2, right? We're going to do a couple of these examples in this video. So when we go right into example 2, the instructions are the same. The only difference is the equation, right? So in example 2, my function is f of x equals sine of 2x plus a root 3 sine of x. So as a reminder, sine of 2x is not the same as sine of x. So I'm going to need to use a trig identity, and we learned a couple of trig identities in the last section. I'm going to need to use a trig identity to replace this. So you may recall from the last section that sine of 2 theta is 2 sine of theta cosine theta. So here, this will be 2 sine of x cosine of x. That's what that entire expression can be replaced with. And then plus this root 3 sine of x. Remember, we're finding the zeros, so this is when this thing's equal to 0. Now, if I look for a GCF, I'm going to see that both this term and this term have a sine of x. So if I take out the sine x, what's left is 2 cosine of x plus a root 3. So this is now fully factored. So either the sine of x is 0. Well, that's going to be when the y on my unit circle is 0, which is the same spots we actually found in the last one, right? It's when x is 0 and pi and 2 pi, right? Or when 2 cosine of x plus root 3 is 0, well, if I solve for cosine, I would subtract the root 3 and divide by 2, so I would get that the cosine of x is a negative root 3 over 2. Well, that's the same as asking when the x on the unit circle is a negative root 3 over 2. Well, the x's are root 3's at the pi over 6's, like root 3 over 2 is at the pi over 6's, and since I want x to be a negative coordinate, I need the 2 that are on this side of the y-axis, right? So my answer is going to end up being 5 pi over 6 and 7 pi over 6. And those are my 5 answers in that interval, right? So again, you're kind of dead in the water if you don't replace that sign of 2x with a trig identity that we know. All right, we're going to do... We'll do example 3, which is our last of the zeros examples, and then we're going to go ahead and I'll stop, and then I'll restart with the other examples in the next video. All right, so for example 3, same instructions, but my function, sorry, switching colors, same instructions, but my function is f of x equals 2 cosine cubed of x plus a 3 cosine squared of x plus a cosine of x. All right, so I set this equal to 0. Now, the first thing I notice is that there is already a really big GCF, right? The first thing I notice is that all of these terms have a cosine. So I can take out cosine of x, right? Because all of these have a single cosine, right? And what's left seems to be one of those secret quadratic trinomials, right? So 2 cosine squared of x plus 3 cosine of x plus 1. So right away, I could start with this factor and say, okay, 0 equals cosine x. That one's already done. That's asking where is the x on the unit circle a 0, which is here and here. So the first two answers I get are pi over 2 and 3 pi over 2, okay? But then I still need to find when 0 equals this quadratic trinomial, 2 cosine squared x plus 3 cosine x plus a 1, right? Now, if you need the u substitution, if you need to call this linear term u and call this guy u squared, that's fine, right? You'd have 2u squared plus 3u plus 1, which hopefully you're getting comfortable factoring, and you could factor into a 2u plus 1 and a u plus 1, and that's great. If you don't need that u substitution, if you can jump right to 2 cosine x plus 1 and a cosine x plus 1, that's great, right? Doesn't matter to me if you need this or not. You just need to be able to factor it. So either 2 cosine of x plus 1 is 0, or cosine of x plus 1 is 0. Well, when I solve for cosine, this one's going to be cosine of x is a negative 1/2. This one's going to be cosine of x is a negative 1, right? So that's asking where is the x on the unit circle, a negative 1/2, and where is the x on the unit circle, a negative 1, right? Notice that I called it x UC, not just x. So x in the unit circle is a negative 1 at pi. So that's the next answer, right? So I have these two. I get this one. And then arguably the most challenging one is where is the x in the unit circle, a negative 1/2? Well, the x's are 1/2 at the pi over 3's, and because I want x coordinates to be negative, I need to be the left of the y-axis. So these two answers are going to be 2 pi over 3 and 4 pi over 3. So again, I end up with 5 answers. It's just a coincidence that we've ended up with 5 answers for all of these, but 1, 2, 3, 4, 5 answers, okay? In the next video, we'll talk about examples 4, 5, and 6.